Okay, this is the one I have to admit, even it took me quite a bit of time to figure out. This one is a little bit strange, but if you get a problem like this where it's sort of a guess and test type of problem on your exam, skip over it and come back to it at the end once you're done the rest of your exam. Leave a problem like this for the end because you don't want to waste a whole bunch of time trying to solve it and then you'll run out of time. Alright, so it says, to solve a particular logic puzzle, x must be placed in 6 squares in the grid below so that no 3 x's lie in a vertical, horizontal, or diagonal line. Which of the following opening placements of the first 3 x's could lead to a successful solution to the logic puzzle? In other words, they want the x's laid out so that there's no tic-tac-toes. They want a cat's game, so to speak, where they want the x's never to form a straight line of 3, a diagonal of 3, in any direction. And as it turns out, through trial and error, you can only have that happening when you have 3 in one. Someone's talking in the background. 3 in a corner like this, and 3 in a corner like this, or 3 in this corner, 3 in this corner. Those are the only 2 scenarios that work. But again, there's no easy, straightforward method of deriving that. You just have to sort of trial and error to sort of figure it out. But anyways, we have our 4 choices here, and we're going to examine them to figure out which one could lead to a successful solution. Okay, so what we know is that we're starting out with 3 x's, and we have to place 3 more x's in order to, have what we need. So how is this going to work? So let's start with B. We have to place 3 x's, and we cannot form any tic-tac-toes. So this spot is not available, this spot is not available, and this spot is not available. So we place our 3 x's here, here, and here. But in doing so, we formed a tic-tac-toe this way. So B is impossible. Let's try C. We need to place 3 x's without forming a tic-tac-toe. Well, this is not available, this is not available, and this is not available because you'd either get it this way, or this way. So we placed our 3 x's here, here, and here. Well, what did we do? We created tic-tac-toe, tic-tac-toe. So C is out of the picture. What about D? We need to place our 3 x's in such a way that we do not form a tic-tac-toe. So this one here is not available. And this over here is not available because you go this way or this way. So we have 1, 2, 3, 4 spaces to put our x's. So let's start by placing, we can't put 2 x's up here because that would create a tic-tac-toe. So let's try putting an x here and an x here. Then we're stuck. We still have to place 1 more x. If we put it here, we'd have a tic-tac-toe this way. If we put it up here, we'd have a tic-tac-toe this way. So D is out. The only possible solution is A. And here's why. With A, only this spot is unavailable. So we have 1, 2, 3, 4, 5 possibilities of where to place our 3 x's. We could place an x up here, and an x down here, and an x down here, and what do you know? There's no tic-tac-toes, and we have 6 x's. Alternatively, we could put an x up here, 2 x's down here. That also works. So our answer is A. 3 experiments and related events. Experiment 1 involves rolling a fair die once. Event X is rolling a 2, event Y is rolling a 6. So obviously, they're 2 completely different events that are completely independent of one another. Experiment 2 involves randomly selecting a number from 1 to 10 inclusive. X is selecting an odd, Y is selecting a prime. Okay, so for this, the events are not independent. Why? Because or excuse me, what I meant to say is they're not mutually exclusive. Sorry, you should never ever get those two mixed up. Mutually exclusive just means that the events cannot happen at the same time. Independent just means that they don't, that the probability of one happening does not impact the probability of another one happening. So, experiment 2, if you randomly select a number from 1 to 10, event X is picking an odd number, event Y is picking a prime number. It's very possible that you could pick a number that's both odd and prime at the same time. So these events are not mutually exclusive. And then for number 3, you randomly choose one marble from a bag. Experiment X involves choosing a red marble, event Y involves choosing a green marble. The mutually exclusive events are described. Okay. So obviously if you choose a red marble or you choose a green marble, those are mutually exclusive. Because a red marble is not a green marble, and a green marble is not a red marble. And same with rolling a die. Rolling a 2 is not rolling a 6. Rolling a 6 is not rolling a 2. They're different. They're mutually exclusive. However, picking a number from 1 to 10 that's both odd and prime is entirely possible. You could pick a 3, a 7, a 5, right? So the only mutually exclusive events are 1 and 3. 1 and 3. So the answer is B.